Yes. Thank you.
Legacy code's everything before you, right?
Yes. Everything I wrote 2 seconds ago, basically. and I do mean that, actually. I think that's one of the big misconceptions about legacy code is that everyone thinks it has to be something that was written 6 months ago, but that's not always the case. It could be something you wrote like a minute ago, a week ago, something like that. Okay, great. Yeah, so I'm going to be talking about that. So a little bit about me. I'm Joe Cabrera. I'm lead software engineer at an AI startup based out of New York called ASAP. I've been a Python programmer since 2009, and I've been working on various legacy code bases for the last 5 years. So the goal of this talk is really to give you the tools to succeed when dealing with legacy code. And I'm really going to tailor this talk specifically towards those of you in the audience that this might be your first time dealing with legacy code. Again, it's probably something eventually you'll deal with in your career, and definitely a ride worth taking. So let's start off with a little definition. What exactly is legacy code? Because a lot of you probably want to know what that is. Really, there's a lot of definitions floating around on the web. So let's start talking about what some of those definitions could be. It could be code without documentation. So here's an example of some random class, and we know that it has a build tree function and a query, but we don't exactly know what it does. We know it's called segment tree. That's not really helpful. Legacy code could also be code without test. So you probably see this a lot if you've jumped into, you jump into a new, some legacy code and it just isn't, there's no test and you don't know what it does, that's kind of scary, right? Also, it could also be code that has poorly written test. So it's pretty hard to update the code. This is a terrible example of some tests that we wrote for this function to add numbers, and we're asserting a couple different things in here, have a couple different sub-functions we're calling. This really isn't a great example of a test, so this is going to be hard to modify in the future as we make changes to the code. Legacy code could also be code you're not familiar with, and often legacy code is not your idea. Maybe you joined a new team or you joined a new part of the company and they just threw you on a project and said, here's the code base, good luck. And you don't know what you're doing. Really, the best definition of legacy code is it's valuable code which you're not comfortable changing. And that's pretty scary. Okay, so we want to improve our code. However, we don't understand it. We don't want to break existing functionality. And really, we don't want to make things worse. Okay, so our plan. Basically, first, we're going to start with understanding the code we want to improve. And then we want to check that our understanding of the code matches what is expected. So we expect this code to perform in some way. And we want to actually verify that what we expect it to do matches reality. We're going to add some tests. We're going to make our changes. And then the most important step is let's communicate those changes effectively to others on our team. Great. So starting off with that first step, what can we do? We can increase code documentation. That's going to be really helpful to fellow developers. So some things we can do, add some class doc strings, maybe. So to this indexer class, we added a small comment saying what this class does. It's a class that adds new documents to our index. We put some information about attributes. In this case, there's an attribute name that's a string that contains the name of the index. And then there's another attribute which is doc count, takes an int. And this is the number of the documents in index, and maybe there's a method on this, say for example, index, that takes index directory configuration, and this just creates a new index. So with this information, now someone knows exactly what this class does. This is very helpful. Another thing we can do is add function docstrings. So we can take each function, break it down, and say exactly what happens there. In this case, there's a function index, and this creates a new index for documents starting at a given directory. It takes a couple parameters, and it returns an object of the newly created index. So now the person looking at this code knows exactly what this function does. We can add documentation to explain logic when it's not obvious. And by this, I mean you don't have to add documentation to every single line of code. In fact, that would probably take a very long time. You probably just want to explain sections of the code that aren't extremely, again, obvious at first glance to the person looking at it. So that first example from before at the beginning, I added a few comments in here to explain what it's doing, and now the person reading this code could more easily understand exactly what this function should be doing. Also, we want to explain mysterious variables, because obviously, usually you're going to run across variables that, I mean, this is a very contrived example. You know, x, what does x do? It's equal to a plus b times p. It's probably usually not that bad, but you get the idea, is that you do want to explain, and I know this is one of the big programming, one of the hard things in programming is how to name variables correctly, that and caching, right? So the idea is you want to try to, have some variable names that are pretty self-explanatory. Great. So now we're going to get to adding some tests. Okay. So when we're adding tests to legacy code, what we want to really start with doing is identifying seams in the code. And a seam is really just a place where you can alter behavior in your program without changing the code. This could be calling an external library. This could be calling an external API, a database in this example. So in this example, we have this function, this class, production class. This is just an example, and there's a function, a database connector. It takes a database object, and we're calling this connect function on it. So we can easily just write a test around this section of code because we can mock out that database object. And we can just do this very simply by creating a mock. If you were here for one of the previous tutorials, they did some more explanatory stuff on how to do unit testing and mocking in Python. So you can just create this mock. And in this case, we're just asserting that the connect function was called. So there's other examples of different seams that we can use in various different programming languages. We probably won't go into all of them in this talk because some of them would deal with parts of other languages that wouldn't be a thing in Python. For example, pre-processing, linking. These are something you might see in another language like C++. But mostly in languages like Python and other object-oriented languages, you're going to have object seams. Here's another example of a seam, and this goes back to that first point that I was talking about. In this case, we have this shipping services functionality. Maybe it's an external API that we talk to, and we want to mock that out. And so in this example, we created a mock object for that shipping service. We're calculating the price, and we're going to set what the return value should be for that, and then we're going to assert what we expect that to return. So a few trade-offs to consider when using seams. Again, the pros to this, we're breaking this code into really smaller sections that are easier to test. And this just helps us get enough tests in place really to support more aggressive changes, right? Because we want to make all these additional changes, but we need to just have some, initial layer of tests in there so we trust the section we're modifying. Some of the cons to using seams, These tests could be hard to maintain by others in the future. And sometimes you can create too many seams in your code, so it becomes very fragmented. And so this is something you're going to have to, think about when you're dealing with like large chunks of legacy code. And sometimes you just maybe need to refactor and kind of like do it from scratch a little bit. Obviously, that's not something you want to do, but when you're using this seams model, this is something that could happen. So with legacy code, it's hard to understand in many cases, and to understand it more easily, we can use a characterization test. These are also called golden master test. With this type of test, basically what you're doing is just writing a test that exercises the code you want to test, and you're comparing the output to the golden master output. In this example, that function add numbers, we're writing a test for it, and we're adding two numbers together, and we expect 5 and 5 when added together to return 10. And so we're really just checking the output of that, of something we know it's going to produce, and we put that in our test. So great, unit test. However, many times you get the answer from someone else, maybe on your team, or for someone else higher up in management that says, we just don't have time to write all these tests. Not the answer you want to hear, but it does happen sometimes. So I have a couple of examples of things you can do when that is the case. You can use two different models, the sprout and the wrap. So for the sprout, we're going to start by creating the code elsewhere, and then we're going to unit test just that section of the code, and then identify where you should call the new code from the existing code, and then call that new code from the legacy code. So here's an example of this diaries update class, and we have this new functionality we want to add to dedupe these entries. And so we can write a unit test just around that one function, and then we're basically just going to call that function from our existing function, in this case add entries. And this is great because we've just isolated that one functionality of the code, and we don't have to worry about the rest of the code. So we definitely trust that new functionality we added. In the wrap case, we're basically just going to rename the old function that we'll be wrapping, and then we're going to create a new function with the same name and signature as the old function. So similar example of add entries. We're going to create this new function, add deduped entries, and then we're just going to call that from our existing function and add the new functionality and add unit tests around that. Great. So once you made all your changes, you can share those with everyone else on your team, and everyone wins. And that's it.
All right. Let's see if we have any questions. Yes, we do. Excellent. Sorry, I was waiting for it to refresh. So let's start with, do you have any advice for how we can convince management to allocate time and resources for managing legacy code or technical debt?
Wow, if I knew the answer to that,
yeah,
probably should get paid a lot more money. No, seriously though, I think you really should make a really good pitch to management, and it's hard to say, hey, we need time to add these tests for the legacy code. But the easiest way I think to paint it to them, because I've done this myself, is say, look, how many incidents do you want this year? And guarantee their answer is going to be like none. And so, hey, if you don't want those incidents, we're going to have to add some tests so we trust the code.
Yeah, it's one of those things you either pay up front when it's easier or pay later when it's an emergency. So, do you have a resource you recommend for writing good doc strings?
Ooh, the Python docs are great for looking at that. That's my biggest hint for that. One other thing I will say, if you want to know more about legacy code, there is a really great book on this, specifically about legacy code. I don't have a link to this, but I'll drop it in the Discord channel.
The next question I think might touch on this. Working Effectively with Legacy Code by Michael Feathers.
That's it.
Is one book on the topic. Do you know any other books or resources you'd want to recommend?
There's another book that I could recommend too. I'll drop that in there.
Okay, awesome. How do you suggest testing legacy code which is heavily reliant on database records in production?
Yeah, mocking stuff that's dealing with production data is always really tricky. I think you want to try to get it as close as you can to what would be in production without having to actually use production data. It's hard.
Yeah. Do you think that even extremely well-documented code can become legacy code?
Definitely. And by this, I mean that even if it's really well documented, sometimes those document notes that are added aren't the best. And so maybe it might even be another step of going in there and making that documentation or those comments better, if possible.
Okay. Do you have any tools to recommend or that you like that would auto-generate basic docstring, like from a template, for all the methods and classes, which you can then go in and update and fill out?
Yeah, I think there's some really great tools for doing that. I can't think of them off the top of my head.
Yeah, I was trying to pull. I know I've used one before, and I can't.
But yeah, I feel like there's one I've used before.
Okay.
If I think of it, I'll drop in the chat.
I know they exist. That's a start, right?
Yeah, they definitely exist.
When writing unit tests, is it better to mock the database or actually create records to test your queries?
I always prefer to create the records using the mock, and then test it that way.
Just using a ephemeral database.
I've done it with an ephemeral database before, but I've also there's libraries you can use that will create records in this like temporal database, and then you can query against that.
Yeah. Okay. Thoughts on type annotations for documenting legacy code?
I think type annotations are always great for dealing with legacy code. I know that's a more recent thing to Python, so if you see like some legacy code, definitely add that.
Awesome. All right, that is all of our questions. Thanks, Joe Cabrera. Appreciate it.